Hello and welcome to the AI First Show. This is the show where we talk about AI applications in business, in your life, how to get things done with AI. My name is Stephen Barr, and it's my co-host Leonardo Gonzalez. Today we're talking about Inference, about GLM 4.7, kind of anchoring this on the recent Cline and Cerebras Hackathon, where they were focusing on GLM 4.7. Let's just jump right into it. Leonardo, how's it going?
Good. I am on my third double espresso, so I'm hoping to be able to speak a little bit more quickly today, especially
Awesome.
since the main topic today is speed. I looked at previous recordings, I'm like, they sound better at 2x speed. So,
Well, I think talking about Cerebras, right? That's Cerebras' thing. They do things fast. Let's have the high energy, the triple espresso, triple double
exactly.
espresso energy. Would jump right into it.
So there's a lot I want to cover today, and I'm going to break it into like three different phases. One is a little bit of a theoretical foundation, and it's highly technical, but it'll be accessible. And it's good for thinking about speed in general and different models, because there's a lot to it, maybe more than meets the eye. And then, dovetail into the hackathon and how those principles relate to things from the Cerebras Cline hackathon and some learnings and findings from that hackathon. And then how those things translate into some emerging trends I'm seeing in the industry for multi-agent orchestration for software development.
Okay, that sounds really fun. But I guess let's first define the problem. So get everyone on the same page. Inference, right? So inference is the part of when you're asking an LLM. There's two parts. There's training and there's inference. So training is when you're actually taking all that raw data and you're saying you're making the model. And then inference is when you're actually asking the existing model a question. So when we go to chatgpt.com, when we go to claude.ai, whatever, when we're using our open code and talking to Olama, that's all inference.
Yes, and there is a little bit of overlap with reinforcement learning where you're doing inference and you're doing training. But for the most part, we're doing inference when we're using models. And people like to think about speed and power and cost kind of as three different components of that. But even speed is not that straightforward of a concept. Like you have to break it down into different parts. So that's what I'm going to start with. And I'm going to show a course that I created for somebody about this. And I'll publish an extended video with the course content. But right now, I'm just going to kind of go through the slides rather quickly so that we can get at least an idea of these principles.
Okay, cool. Let's pull up these slides. And while you're pulling that up, it's actually interesting. I wanted to highlight how fundamentally with hardware, they're different problems. So much so that AWS, I've got one of the AWS shirts on, they've got Trainium custom silicon and Inferentium custom silicon because there are different problems in terms of like the quantity of data flowing and what you want to do. And it reminds me, like, you think, okay, just buy a great GPU and you'll be good at both, but that's not necessarily the case. It reminds me of the classic Mitch Hedberg joke of he's a comedian and they ask him to write a show, and it's like, oh, that's like saying you're a great cook. Can you farm? And it's the same thing with training and inference. They're different problems, different skill sets, different hardware. All right, so let's have a look at your course.
So the first part here, talking about inference, this is kind of the overview of the first part. There's different phases in inference. A lot of people don't know about this. It's prefill and decode, and it's essentially the input and the output, and they are very different in nature. And then the metrics that we then assign to inference, like tokens per second for throughput or time to first token for latency, how concurrency and batching come into play, and then looking at aggregate throughput instead of individual streams. So this first part of the two phases. The initial phase is prefill, and that's essentially processing the context, the prompt, the spec, the huge input. Because it's already known, it can be done in parallel. And so this is benefiting from high parallelism, parallel processing, determined by kind of multiplication of operations. And then using the KV cache, populating the keys and values. The primary metric here is the time to first token, and that's kind of the delay between you sending a prompt and having it process and think, and then starting to see the response. And it is a very different set of operations and performance than the other phase, which is decode. Decode is the output when it starts generating tokens. And because these are autoregressive transformer models, which means it's kind of a next token predictor, you can see the streaming responses as they come in, different than diffusion language models, which is something we can get into at some point, where it just kind of creates all the words in random order and fills them in. Here we do one word at a time. So every word depends on the previous word or token already being generated, which means it needs to be done sequentially, one at a time. And so here there's a different bottleneck, which is the GPU memory and being able to move information back and forth. So here we look at a different metric that is tokens per second in each stream, which is how fast are we generating these tokens. So those are kind of the main two phases of inference, and we have to think about them differently.
So it's kind of, to bring it back to the Mitch Hedberg analogy, the time to first token is like, when does the breadsticks come out? That's the first thing. And then you're kind of happy. And then the next one, the decode phase, it's like, well, are things going well in the kitchen? Is the soup coming out? Is the salad coming out? Is the rest of the flow happening?
Exactly, yeah. So the first part is how quickly do you see something, and what is the latency essentially, and how quickly can you process the input? And this is something that depends on the reasoning efforts too. And then the other part is the decoding, and that's kind of the throughput of how quickly are you making changes, are you sending output, and this is also very visible to the user of like how quickly do they get their answer back. One distinction to make, though, is the single user or single stream or single agent tokens per second being different than the whole aggregate. If you have multiple users on a system or even multiple sub-agents from the same user using a system in parallel, then kind of looking at the total throughput instead of the single session throughput. And that's going to come into play for sure.
So back to the analogy, your favorite hole-in-the-wall place could maybe get your order fast, but if a football team shows up, they might fall over compared to the throughput of like a chain.
Yeah. Or vice versa. It could be that like, you go into a place and they don't get you your order right away. There's a little bit of a delay, but even if you come in with a large group, everybody gets their order in a reasonable amount of time. So these are kind of the kind of trade-offs that you look at, the latency and the throughput. And what's interesting is the optimization of those two as you increase concurrency, depending on the setup of your system. And there is this kind of sweet spot, which is as you increase concurrency, you're going to be increasing your overall throughput. Your throughput initially, if like you only have a couple of orders in the kitchen, you're not putting out a lot of food at once, right? And so you look at the total productivity of the kitchen, you would consider it low. But then if you start adding in more and more orders, you get to a point where like, wow, yeah, you got a lot of output. But then if you increase your concurrency beyond what your kitchen can handle, then everything just falls apart. You essentially have lower throughput in addition to higher latency. So people are waiting longer to get their food, and the kitchen is getting stressed out, and things are getting delayed and falling, et cetera. And so there's definitely a lot of calibration and optimization when you're looking at inference setups to make sure that you have the right concurrency to get the most out of your system and not leaving idle computing resources, but also not to be oversaturating them so that they're getting overwhelmed.
That makes a lot of sense. And that's why I encourage people to go look at the local llama subreddit, even if you're not running it yourself, but just to understand the discussion of what goes on in order to make these models work. And they talk about these trade-offs and how much room to save for KV versus how much VRAM to save for the actual process. It's just neat to know about all this stuff, even if you never actually do it yourself.
All of this exploration in this course came about from this desire to explore speed for development and what kinds of models and what kinds of inference options could there be. And I had a couple of thoughts on there. The main thought that I had was, let's get out of the mindset of using the most powerful giant model for everything, and let's look at different use cases where maybe we have 2 or 3 different tiers. We have some kind of a frontier tier for complex things, architecture, the specifications, and you have some like really fast tier for writing code and for actually doing operations for kind of brute force, low intelligence, high throughput, high speed. And this is a very recent model that came out that is very promising for that. It's a GLM 4.7 Flash. It actually fits on consumer hardware. It's 30 billion tokens with only 3 billion active, mixture of expert. And consider possibly a middle tier that can do quality control on the fast work, that can do some reasoning, but is also fast, much faster than these super complex, heavy models, and it's kind of a spot in between the two. And this is kind of what I was talking about, where we have these 3 different things that we want to optimize. One is the quality, the reasoning, the accuracy, the intelligence, the sophistication. The other is the cost, and the other is the speed. And you can't have all 3. All of those are kind of in opposition to each other. So you have to either figure out where you want to optimize or have orchestration of different models that have different strengths for your different use cases.
And we see this all the time in like human organizations, right? So like the GLM 4.7 Flash might be like the intern, right? Where they're fast, they're responsive, they might not get everything right. But, if they're managed well, right, then you can get a lot out of it because it's fast and you have this level, yourself managing the intern, saying, okay, try it again, try it a different way. But then you don't have to go and do those tasks. They're paid less. But it's we see this type of model a lot in human organizations as well.
For sure.
Right? You don't just have an organization that's all CEOs, all Opus 4.5.
Exactly. So here, I'm presenting Opus 4.5, but right now I am actually, and a lot of people are looking at GPT 5.2 codex with extra high reasoning effort as an even better model than Opus 4.5. The main drawback there is not the cost, and that's the interesting thing. It's a better model in many ways in terms of hallucinating less, creating bugs, but it costs a lot less, but it is a lot slower because it thinks really, really. I mean, you can control how much it thinks, but obviously the more it thinks, the better its output is. But then it's really slow. So if you're looking at optimizing kind of your overall throughput, you don't want something like Opus 4.5, and you definitely don't want a GPT 5.2 codex with extra high reasoning on your critical path of speed. But you do want it for things that you think you need to think really hard for architecture, for specifications, for analysis, for planning. These are things where measure twice, cut once, right? So the more you can have things well designed in the first place, the less mistakes you'll make. And then I'll show you some learnings from the hackathon of seeing another place where these models can come into place for sure. I talked about the mid-tier, and this is something that I got into in the hackathon of looking at the capabilities of GLM 4.7. I had used it for some vibe coding in the past, and I kind of really put the model through its paces here on an interesting project. And this is now the model that is being served by Cerebras for their coding plan and in general as kind of their frontier coding model. It is a good model to become familiar with. And then this is the model that I said very recently came out, which is sized for local inference. And not just the size, but the speed. When you maybe put this on some powerful hardware, you can look at some very interesting numbers as far as what's possible. And that was one of the questions I wanted to explore.
When we say local inference, we're talking people who have like an RTX 3090 or a 4090, 24 gigabytes of VRAM. So you can know if we've ever running Opus on this if it was open. But
exactly.
a good GPU, even one that's 5 or 6 years old in the case of the 3090, a good GPU and
or a Mac.
You can do that. Yeah.
If you've got Apple Silicon and you've got unified memory, then you can run these models locally. But one thing is to have a, 5,000 or I don't know how many $1,000 Mac Studio M4 or whatever, and another is like just a laptop that is like maybe an M2 or an M3 that maybe has 32 or 64 gigs of unified memory. And for those, you run lighter weight models. Like you'd be able to run GLM 4.7 Flash a lot more easily than the full-size GLM 4.7. So figuring out where each model fits and where to use each model, that's what I'm going to get into toward the end as well. I'm talking about multi-agent orchestration. There's some very interesting movement in the industry of getting beyond doing everything in a single conversation with a single agent, with a single model, and starting to think about it as an orchestration of virtual employees or agents or different models. So very quickly, I'm just going to talk about a couple of more things. I'm not going to get too much into the mechanics of a lot of these pricing analysis, but I wanted to talk about a couple of different things. The main two things that I wanted to compare, which was a cluster with 8 high-end GPUs, like B200. This costs like $44 an hour to rent. It's not unreasonable. Obviously, if you do it all day, every day, it's going to be astronomical. But if you start to think about it in terms of dollars per token and time saved, it could be worth paying a lot of money for a lot of tokens in a short amount of time instead of having to drag it out. I was saying this yesterday that if you maybe have a senior engineer that needs 1 million or 100 million tokens to do some project, then it's just a matter of like, do you want those 100 million tokens over the course of 2 days or over the course of 2 hours? And if they can do the project in 2 hours instead of 2 days, hey, that's a saving.
So you could spin up one of these machines and say, read all of my source code. Say you wanted to do some big refactoring over this large corporate code base. You could say, read all my source code and come up with a to-do list, come up with PRDs and architecture and all this stuff, and then unleash a fleet of, Haiku and Sonnet and 4.7 Flash, all this lower models, which is exactly what we see in human organizations, which makes sense. I wanted to point out also, let me share my screen for 1 second. This is a stream that I want to do. So this machine, this 8 machine, you can get this right now for $26 an hour on Vast. And so you can experiment with this. It doesn't, again, don't leave it running overnight or forget about it. But using it for 2 or 3 hours for a job, that's pretty reasonable, especially considering that this is a $200,000 machine.
Wow. Yeah.
All right, I'll put this. But I'm going to ask Perplexity, how much is a 8x B200? I'm very. Anyway, sorry. Let me put yours back on screen. We'll keep going.
All right. So basically, being able to use all 8 GPUs, with this high bandwidth communication between them, opens up a lot of. An interesting thing with a model like GLM 4.7 Flash is it'll fit on a single GPU. So you can load individual instances of it and start to serve it in parallel. And so that's where you can start to look at aggregate throughput. If you have a fleet of agents and sub-agents and you're hitting 8 or 16 or 32 concurrent requests, you're going to get some much higher total throughput than just the one conversation at a time. And that's where looking at the aggregate throughput is going to be really interesting. But it means that it's a really complex question to look at, the speed. Speed is not a single measure. You have to look at prefill versus decode, you use single versus aggregate. And a lot of it depends on your individual use case, throughput versus latency. But you can have a single power user with a lot of these new orchestration frameworks hitting a node even harder than multiple users through individual conversations. So we're getting into the age where a single power user is going to unleash a swarm of sub-agents, and it's going to be such an inference demand that now you have to start to think about, well, what's the best way to meet that demand? Is it through something like Cerebras? Is it through GPU APIs? Is it through your own rented GPU cluster? It depends on the model that you want to serve. It depends on your overall scenario of your multi-agent orchestration. So this is basically bringing more questions than answers, which is good. It forces you to think about a lot of different factors and realize that the question is maybe much deeper than you realized. But overall, when you're looking at a GPU cluster, you want to think about your cost per hour of renting the node, and you want to think about how many tokens per hour can you get out of that cluster. If you have it to its full capacity, if you're pushing a lot of concurrency, you've got a lot of sub-agents, then what's the maximum amount of tokens you can squeeze out per unit time? And then that's going to give you your unit economics of then what's your dollar per token. And kind of the main two things that you want to look at is your speed, right? Like how fast can I get, how much throughput can I get? If I want to get my 100 million tokens, can I get it over the course of 2 hours instead of 2 days and bypass rate limits or hardware restrictions? And then what's the cost? Like, is it going to cost a lot or is it going to cost less? And those are two important considerations to have in all of this.
Well, I think we're in such a strange universe in terms of prices. So it's really worth understanding how to be flexible with all of this. So I want to show this on my screen real quick. So it's actually this 8X B200 box. They said low to mid 7 figures. Okay, so its predecessor was about 600,000.
Yeah.
So it's like low to mid. So this is like saying, okay, imagine you could rent a Lamborghini Revuelto, and you could get that for $25 an hour, and it mysteriously appeared in your driveway when you clicked a button, and then when you're done with it, it vanishes. Like that would be pretty cool. Like to think about this, where like there's some $1 million machine that you could use for $25 an hour.
Yeah.
That's pretty neat. And so you want to be able to take advantage of this. And if you do things the lazy way, just say, I'm just going to opus everything on Amazon Bedrock, that's going to be like astronomically expensive for you. And maybe you don't care, but you'd want to learn, for most people who are budget constrained, you'd want to understand, how do I adjust my workflow, my batching, my usage of these models to do things the right way. Like it's just like if you're ever talking to a lawyer, right? You want to have all your questions in a row because you're paying $600 an hour. So you want to have all your questions ready. You're not going to shoot the breeze and talk about the weather for 45 minutes. No, you're going to treat them as a very expensive resource that
and also think about a whole law firm. So I mean, cost is one consideration. The other is the throughput, right? So do you want to hire an amazingly expensive lawyer, or do you want to go with a prestige law firm that maybe has some partners and some junior partners and some paralegals and is going to put maybe a team of 10 people on your case or 20 people? Cost aside, you're going to maybe have a lot more throughput, so to speak. So
exactly right.
Another consideration.
And sometimes you're paying for the $600 an hour professional, and then sometimes you're paying for 4 paralegals. And,
exactly.
And then the orchestrator, right, the main lawyer, kind of knows what jobs are appropriate for what task, and that's exactly what we want to do with this GPU, right?
Yeah.
When do I want to use the big expensive one? When do I want a team of cheap ones? How do they interact? How do I get the most out of all of this pool that I have access to as a whole? I really like this concept. Let me put your course back on the screen. Would you keep going?
Yeah, so let's talk about Cerebras now, which is the topic of the hackathon. They have what they call a wafer scale inference. There's these giant silicon wafers. They're pretty large. And
it's like the size of a Frisbee, like a big Frisbee.
Yeah, a little bit bigger, maybe like a large pizza. And they're usually, kind of cut up and used in different GPUs. But there's a lot of overhead that comes in connecting the different GPUs. So Cerebra's approach was to take one giant wafer and put everything on there. And basically, they have optimized their setup for incredibly high inference speed. And they have different options that we need to look at. I'm not going to get into too much detail about them, but they have some subscriptions. They have Code Pro and Code Max subscriptions, and they have certain price points and rate limits on requests and tokens per minute and per day. And they also have a pay-as-you-go with different tiers, free, developer, enterprise. And they have different models. They have GLM 4.7 and GPT OSS 20B. And so there's a lot of variables that you have to kind of keep in mind and calculate when you're trying to figure out your possible throughput, your possible costs, and what models that you have. So I mentioned a little bit about the architecture. You can get things that are just impossible with GPUs on the scale that what Cerebras does, and but it is inference. So this is not something for training, but it is highly optimized for inference. And what you're going to get is very, very high throughput, your tokens per second on your decode especially. What is interesting is that you have to look at not just the limitations, but the quotas. There's a very detailed managing of limits on tokens per minute, on requests per minute, on tokens per day. And so those limits depend on your tier, and they also depend on your subscription, if you are lucky enough to have a subscription. They have waitlisted most of their model subscriptions right now, so you have to wait and beg and plead and hope and hopefully eventually get in order to take advantage of some amazing pricing discounts.
So to give people an idea, like if you chat with ChatGPT or Claude just on the regular web interface, you're a regular pro subscriber, you're $20 a month, you were getting maybe 80 tokens a second. Right, yeah, and you can see the chat kind of fill in, maybe less. Cerebras is 1,000, 1,200 tokens a second. So you don't watch it fill in the way you do with ChatGPT or any of the other models.
Crazy fast.
It's just there.
And it's amazing when you see, and I'll show a video behind the scenes of the hackathon. It's amazing to see the speed that the code comes in at. So here, I talked about the two main ways of using it. The subscription, highly subsidized. Again, you're looking at like 6 cents per million tokens if you use it to its full capacity, compared to maybe you're looking at a couple orders of magnitude or an order of magnitude difference when you're looking at pay-as-you-go quotas. And different models as well. We've got the GLM 4.7, and that is kind of the mid-tier model, or people consider it kind of a near frontier, but it is priced at a premium. It is not terribly cheap compared to GPT OSS 120B. And then look at the speed too. This one's 3 times faster and about 1/10 the price. So this is kind of like if you were using GLM 4.7 Flash, it's not as intelligent, but it is crazy fast and it is crazy cheap. So it is something to keep in mind. You may be able to, even as an enterprise, get both subscriptions or on pay-as-you-go and use both models in some kind of an orchestrated way. And so one of the main limitations of Cerebras is because of their rate limits, you can have an amazing experience as a single user with your tokens per second. But if you are launching many sub-agents, you're going to hit those rate limits really quickly on a per minute basis because of the aggregate throughput. So that is something that depends on how you're using it and the limits that you're going to run into. I already mentioned model selection and thinking about how to measure this stuff. So I think now we can transition to this part is in real time. There's parts that I've cut out or sped up, but here I'm just showing you I'm using Cline with Cerebras. You can see at the bottom there 4.7. You can see hundreds of lines of code come in under a second. So it is just mind-boggling that you can get thousands of lines of code in a matter of seconds. And that was all real time. I did not speed that up. And what I implemented there, or attempted to implement, was something similar to Claude Dojo, which is a multi-agent visualization for Claude Code, but to do it for Cline CLI. I did have some issues. You can see there, I'm saying still not working. You know, I'm running into issues, and one of the drawbacks here is that the model wasn't able to do its own testing and have its own feedback loops. So I had to kind of copy and paste the DevTools console for the web view. Like, here's the JavaScript logging, and here's the output of the pane. And so that probably made it a lot harder than I needed to. And this stuff could be wired in automatically. It would take some effort, but it could be done so that it would not be kind of coding in the blind. But I did do this a few times where I would kind of paste the errors, and eventually I realized I needed a more intelligent model to help with the debugging. So I used GPT 5.2 to create the spec in the first place. And then I started saying, hey, you know, I have an agent that implemented this. Here was its response. And here's what I see in the DevTool console, and copy all the things. And it was able to find the issue and figure out what it needed to do much better than the other thing, kind of just hitting its head against the wall, trying it and trying it and trying it. So this kind of turned on a light bulb for me, realizing like, okay, one model is really good at writing lots of code really fast, but if it runs into a bug that it can't figure out, it's worth spending the time and money for another agent, another model, to think about it more deeply and pinpoint exactly what the issue is, and then tell that to the other agent again, saying, well, actually, here's the analysis of what's wrong, and here's the analysis of what you need to do. So I did that a few times. And one thing that I noticed was, here it says, perfect analysis. You're absolutely right. You can tell that GLM has done some training on Claude's outputs.
Yeah, that sycophantic encouragement.
Yes, and even the self-congratulatory use of emojis after it says, oh, I did it, look at everything, ready for production, ready for deployment. And I got tired of that. And I said, hey, the self-congratulatory agent, response completely misses the point. And this is really interesting because
you get mad at these things.
I love yelling at models. And so I can get one model to yell at another model for me. And look, it says, stop writing status updates and implement transcript visualization. It's awesome. It's like, okay, now it got into the persona of, a supervisor trying to get an underling who is fast, but maybe not very bright to do things better. And I realized, oh, this is the future. I can stop yelling at LLMs and get LLMs to yell at LLMs for me.
There you go. Well, and this is where having this experience of just getting in there and doing things and trying. And I appreciate you've given me lots of good encouragement in order to try different models. Like, I was doing something with Sonnet the other day, and I was having this strange Google Auth issue. I was trying to get sign in with Google Auth to work. And I finally said, I just paused that model, switched over to Opus 4.5, and said, really think through this thing. And it worked. And the 15 minutes I spent with Opus, cost as much as my previous 4 hours with Sonnet, but it fixed it. Yeah. And I was able to move on because that's not countering my time, which also has some value. So I had to go and proceed with my day of, okay, let's get the rest of the project done. And knowing where that trade-off is and being able to identify, okay, this agent or this model is out of its depth, or the capabilities are just not working. This is too much context, and knowing when to switch, has to come from experience of just building stuff and using these things.
Yeah, and then this is the kind of thing where I want it to be automated. I want it to be orchestrated by some tool. I got into a good flow state here where I was going here into GPT 5.2 with extra high thinking and doing the analysis and pasting the command to the blazing fast GLM 4.7 on Cerebras and having it to do hundreds of lines of changes of code in a couple of seconds. And I think it got an optimal combination of speed and intelligence. And it worked really well. And this is something that, and I'm going to share my screen now because it seems like that has finished.
There we go.
I was able to do this. This Claude Dojo, this is kind of what I was mentioning, is what inspired me to do the Cline Dojo for Hackathon, is a visualization of multiple agents. Although right now, these are all kind of parallel things that are independent, and each one of these has its own conversation, has its own set of tool calls. But there are some interesting things being done for orchestrating multiple sub-agents as part of one main thing. There's something for open code that you probably will want to check out called Oh My Open Code. And it is an orchestration thing that is everybody that loves open code especially loves using Oh My Open Code. And they have this concept of a planner and an orchestrator and this way of managing multiple different things. Even the agent harnesses in general have this concept of you can use one model for your spec and one model for your implementation. And that's kind of a beginning in the right direction, but it's pretty limited as far as looking at a more complex orchestration where you maybe want to have a quality control agent and sub-worker agents. There's another interesting thing happening right now in Claude Code, which is people have looked at, this is closed source binary, but they can kind of reverse engineer it and do some analysis of strings. And they found this functionality that is behind a feature flag that allows creating these teams where you've got like a leader and different agents working in parallel. And we've looked at different kinds of use cases of different squads of teams. Somebody has figured out how to permanently turn on that feature flag and kind of hack the build so that you can use this already. So this is not generally available, but if you wanted to try it out and you learn about this, then you'd be able to check it out. Apparently, this is all inspired by the that kind of know. This is called Claude Flow. They've noticed a lot of patterns that are repeated. And this is something that is generally available and has been out for a while. And it is this third-party orchestration platform for Claude Code that allows this kind of swarm paradigm for specialized agents and coordinating agent teams, working across LLMs, which is really important, and plugging in. So I say this all because it kind of brings together everything that I was showing from the beginning of looking at different tiers, looking at different models with their strengths and weaknesses. Do you want to have a powerful model take care of this request to write your spec or to analyze something difficult? Or do you want to have a fast model to write several hundred lines of code that you don't want to spend the time or the cost for a large model to do that thing if it's not necessary?
There's one that I've been looking at. I'm not sure if you've seen. There's one called Open Code Workspace. It seems like it's just a person solo project, but it looks neat, right? It's again this idea of okay, you've got agents for researching, coding, writing, skills across planning, code review, injecting code philosophy, right? About security, about best practices, variable naming, all this stuff. And I think that we're in this real heyday of figuring out how we use all this stuff. And there's a lot of these different frameworks for how to orchestrate agents. And everyone's trying to figure out and experiment and kind of what works. For me, it reminds me of, do you remember kind of like the late 2000, like 2006, 2007, 2008? I don't know if you were in the Linux desktop world where everyone was trying, okay, I'm going to use this window manager and this compositor, and I want to get my desktop to rotate on a cube. And it feels like everyone had their own setup. And this feels very much like it, but it's kind of more exciting in a way because it's about productivity and not just making your desktop look super cool. Yeah, we're all trying to figure this out.
What's interesting is that trend. I think they're kind of parallel trends, somewhat orthogonal, that they're going to interweave. One is this obsession with visualizing multiple agents. There's even people writing Warcraft-inspired, like real-time strategy. I want to have a game where I'm managing my agents. And then the more architectural a concept of let's orchestrate a bunch of agents with different roles, with different models, with different skills, different MCP servers, and let's look at what a swarm of agents on a project looks like. And I think those two are obviously going to merge so that you can have a visualization and a management interface control plane for agent swarms. And it's fascinating because I'm seeing it unfold before my eyes, and it hasn't, but it is happening.
If you had kind of the Age of Empires or Total Annihilation interface, where you say, I've got a bunch of scouts, or I've got my trebuchets, or all these things which could represent different models at different price points who have different skills. Oh, that would be kind of fun. Oh, I'm going to send this fleet of siege units over to hit my PRDs. Right. That'd be kind of cool. All right. I got to see this. I think this is another live stream that we need to talk about. So how was the hackathon? How did it end up? What was the winning entry?
So the other interesting finding that was surprising to me, and I'm going to share it. Yeah, so I had very limited time to work on my hackathon. I was happy that I got a working thing, right? I had I didn't actually show the, here, I'll share the demo video.
Yeah.
Another video file. The first one was kind of the behind the scenes implementation of a 3D visualizer of multiple Cline CLI sessions that shows you their tool calls and responses, the prompts and the responses, and multiple agents and the tool calls that they emit in a 3D visualization. So for this project, I have developed a VS Code extension that I can use to use Cline, look at different agents and their conversations and their tool calls and visualize them. One great technique that I found was to develop a spec with a high-end model like GPT 5.2 Pro, implement it with GLM 4.7, and then do any kind of debugging feedback loops with GPT 5.2 again, and keep bouncing back through to GLM 4.7 for the implementation. So here is one of the sessions that I've done in Cline CLI, and now here you can see the visualization of these sessions in a 3D space with the different tool calls. And this is a good way to keep a handle on multiple parallel sessions and be able to look at their conversations, look at their tool call execution. There have been a few of these kinds of projects rolled out in the community. And I think it's the future of multi-agent orchestration for long horizon agentic development. So this is a working end-to-end example. Obviously, it can be extended quite a bit more, but it does have a web view, 3JS, 3D rendering, multiple Cline CLI sessions, and their tool calls. So what was for me was just right now looking at my usage, where on Cerebras, I wanted to see, okay, how much did I use? I only worked on it for a couple of hours. And you can see I used 13 million tokens. So obviously, if I had been able to devote the full 24 hours and use 100 million tokens, I could have a much more polished product. But in a short amount of time, I was able to do a lot because 13 million tokens in a couple of hours is not bad. What was surprising to me was the proportion. So we've got 13 million input tokens and 151K output tokens. That is very different than what I thought it was going to be. But that's because of the amount of input with the spec and then all of the code changes. I guess every piece of code that needs to be changed is an input. But we're looking at 100 times more than output. And then that's going to come into play when you think about pre-fill versus decode and what can be parallelized. So these are the kinds of things where you have to try it out and you have to benchmark it in order to understand what your usage patterns are. Because then when you're looking at pricing, API-based pricing, that is very different for input versus output, then you're able to bring that into account when you have to calculate kind of a blended rate to know, okay, I have 100 times more input than output, then what's my average rate going to be?
And that makes sense, right? You have, depending on the task, right? Like if you, right? If you could, read all of these books and tell me, I don't know, give me one sentence of a strategy of what do I do next, right? That's going to have all input and one sentence of output. And depending on the task, you could have it be the inverse, where you say, write 1,000 test cases, and it's one sentence of input and 1,000 pages of output. So yeah, it's really neat to explore that, not just like the final bill, but actually understanding the pricing structure.
What was interesting was I would think maybe a spec-driven development would be more leaning toward the output, because like here's a spec and now write me an entire code base based on that spec. But I think it's because of the iterative process that there were so many challenges and bugs and issues that it had to read the code and write it and read it and write it and read it and write it. And that, I think, really changed the proportion of input to output.
Here, I'm gonna look at the pricing. I'm just curious. So this is the Cerebras. Let me make this bigger. Yeah. Okay, so $50 a month, you can send 24 million tokens per day. It's not saying what you're getting out of it, but sending 24 million. Here's their developer kind of more a la carte pricing. So you were using GLM 4.7 at 1,000 tokens per second. You get 225 per million in, 275 per million out.
Yeah. So here, let me share my screen. I'll show you my disadvantages that I had. I had an unfair advantage, which is that at one point, I had the plan. And if you go to limits, like I'm on the enterprise tier. So these are insane limits. I've got a 720 million token a day limit. The disadvantage is that I'm not on the coding plan now. The subscriptions, which I'm not seeing on here, I think you have to go to, here we go. As I mentioned, they're all sold out. So I had to do pay as you go. So I spent $45 in a couple of hours.
Okay.
So that's about, like renting out a GPU cluster.
That's a good point. So yeah, the pricing of this is still, one of the dimensions that we have to manage. Mm-hmm. Okay, so overall, what did you think about, like, what is the biggest advantage of having super fast inference?
Obviously, leveraging your human time better, right? There's nothing more frustrating, or it gets you out of the flow, like waiting. I saw something that Latent Space, one of my favorite podcasts, was talking about, like this sweet spot of maintaining a flow state, and it's a matter of how many seconds you wait in responses. And if you have to wait minutes, like you lost your flow. Like now you're gonna do something else, you're gonna get distracted. Being able to stay connected and get a lot done in less time, being able to iterate quickly, being able to advance. Obviously, if you're looking at a super fast model that isn't frontier or with a high reasoning effort, sometimes it's not the fault of the model. It's just like, how much are you allocating for inference time scaling, for your reasoning traces, right? And so if that's the dial that you turn, it's going to be slower, but then that's going to help unblock you. So you really have to find the balance between doing something fast and figuring out how to do something well. It's definitely way too much of a bottleneck in terms of time and in terms of cost to be using a high reasoning effort model for everything. I mean, that's kind of what I've been trying out. I've been enjoying using GPT 5.2 codecs with extra high on several agent harnesses, Windsurf, on OpenCode, on Factory, but it was a very interesting exercise for me to see hundreds and thousands of lines of code fly by with GLM 4.7 on Cerebras, and it made me think, I want to find a way to orchestrate this so that I can make use of powerful reasoning models and lightning fast inference models and have them work hand in hand.
So, okay, here's an interesting thought experiment. Like, remember in the movie The Martian, where they had to communicate with Mars, and Mars, depending on where Mars is and Earth are, it's like between 5 minutes and 20 minutes, depending on where they are in their orbits. And so imagine if you're best on Mars, that's where the server was. Like, would it change the way you use them, right? If you had to wait just like 20 minutes to get an answer, in theory, maybe it shouldn't affect how you use them, because you were waiting to ask the really important questions and being a bit judicious with with stuff, right? Like if I had Albert Einstein next to me, yeah, I'm going to say, hey, if I throw this ball, what happens? Like, probably don't need Einstein for that, right?
Yeah.
But he's right there, so I'm going to bug him. Same thing.
That also like brings into play the whole concept of latency versus throughput. And remember tapes, data tapes, backup tapes?
Oh, yeah.
There was a famous saying, I don't remember who said it or the exact wording, but it was like, never underestimate the throughput of a station wagon full of backup tapes streaming down the highway. And it's like, yeah, if you have to wait 8 hours for a station wagon to go from San Francisco to LA, but that station wagon is packed with how many zettabytes of backup tapes? Like, what is your throughput? You know,
yeah,
like,
it would be faster than just hitting download and waiting.
Oh, yeah.
Great connection.
Yeah.
So, but the time to first token is the time to all the tokens.
Yes.
All right. Well, I think it's been a really fun conversation. I'm looking forward to seeing what's the next step of the hackathon. What was the hold on. Okay, so what's the next step in terms of the hackathon, Cerebras usage? Is it good changed your workflow?
Yeah, so the hackathon, we'll see. You know, I mostly use it as a learning experience. As far as the project, I had wanted to do a multi-agent harness visualization inspired by Claude Dojo, but I had wanted to do it in Zed because Zed is an amazing IDE that is written in Rust and has GPU acceleration for the interface. And they developed Agent Client Protocol, which is a standard way for agents to communicate with client front ends like IDEs. However, they don't have a web view the way that VS Code does. So the first thing I was going to try to do was implement a web view for Zed. You know, it's a challenging project, but the challenging projects are great things to unleash on these agents and kind of test their capabilities. So I'm going to continue to explore and keep contributing to Claude Dojo and also start to think about not just visualizing parallel agents, but visualizing and managing orchestrated agents from these frameworks that I mentioned and other frameworks, or building my own frameworks. To think about swarms and how do we visualize swarms and how do we manage swarms, how to have some element of dopamine in there. I don't think having a real-time strategy game is probably the best interface in the long run, but something that gives you feedback, that keeps you in a flow state, that keeps you engaged, and is aesthetic. So these are very interesting problems, and I'm very excited to work on them. As far as Cerebras, I've mentioned to them that I would like to resume my coding plan. I had it when it was Qwen 3 Coder, and that was a great model when it came out. It then was no longer competitive as other models were deployed. But now that they have GLM 4.7, I think it would be a good time to resume. And it would definitely change the economics of being able to explore high throughput, low latency inference without worrying that I'm spending $50 an hour.
Well, we're going to try and get someone from Cerebras on this show, interview them, really want to understand where their use cases fit in, what they're seeing. And then what you were saying about the interfaces, I think this is the most exciting time because, probably for some people, a real-time strategy game is the best way. Or maybe for someone, I don't know, there's some kind of Tetris-like interface where you're trying to match the problem shape to the agent shape, right? It all depends on what you're trained to do, but because making stuff in general is so cheap right now, you can spend a weekend making your own visualization and say, okay, this is how I think about things. I'll do another episode on this, but I've made my own to-do list system that's always how I visualized it, and previous to LLMs, I'd always had to map my way of doing it to whatever existed. But now I can have exactly what I want, and very empowering in terms of, okay, now I've got a visual that's how I always visualized it in my head, but now there's no impedance mismatch between what I thought about it and how the software I was using, because it was never economical to write my own, and now it is. So I want to share about that, but I think what everyone can kind of make something that works for them, and then we can let the marketplace of ideas see which ones are more general, and maybe someone will have the Age of Empires or StarCraft agent management system that works for them, and people could do whatever works for them.
Yeah, and I think it would be interesting to see the full potential realized of a lot of these standards like A2A, like ACP, like AG, looking at how to coordinate information and instructions between agents and user interfaces.
Yeah, and it takes some time for all this stuff to come out, right? Like, just like when MCP came out, I thought, okay, we're really calling a whole other server just to run ls on my directory. But now, like, we've kind of figured out how it fits in, and it's great. It just takes some time for all the ideas to kind of distill and see what happens. All right, well, thank you so much for your time, Leonardo. This was a really fun discussion. We're going to have links in the description to Cerebras, to all the models we talked about, to Claude Dojo, which is a project of Rahul Subramaniam, to Cline Dojo. Is Cline Dojo available yet?
There's a repo. I wouldn't say it's a polished product yet, but eventually it'll get there. And I'll publish the course that I shared as well, or I mean some of the videos from it. Not the interactive pieces, obviously, but I think there's a lot of interesting theory there that people will benefit from learning.
Sounds great. And most importantly, for all your viewers, just keep building, keep learning stuff, keep trying all this stuff, because that's the way you really learn, is just try it out. And there's so much interesting stuff right now. And join our Discord. Leonardo and I are always there. Pick our brains. I'll have a link down below and in the description. Join our Discord. Come chat with us around. Just talk about best practices, ideas, and we're all in this together. All right. Thanks, everyone. Take care.
Thank you.
Okay. I'm going to hit stop. I think that was a fun episode. I think there's a lot of stuff here. Okay.
Still says live.